Hello, students. How are you? I hope you all are fine and enjoying your online classes and making notes and do revision questions. So, in the chapter third, we will start it some concepts as Arrhenius concept of acids and bases. I hope you will be understand. Now, we read about the classification on the basis of concentration. Okay. Acids classification we will be reading, and on the basis of concentration of acids, how they will be classified. So they will be classified into concentrated acid and dilute acid. Concentration of acids refer to amount of acid present in a definite amount of its aqueous solution. It can be expressed in several units. For example, a 40% by weight acid solution means that 40 gram of the given acid are present in 100 gram of its aqueous solution. That is, 100 gram of this acid solution would contains 40 gram of the acid dissolved in 60 gram of water. So it means 40% means 40 gram of acid dissolved in 60 gram of water. Okay. So like that, one two categories concentrated acid is the acid solution containing a relatively higher percentage of acid is called a concentrated acid. Okay. And the acid solution having a relatively lower percentage of acid is called dilute acid. It means dilute means in which water is present in more amount, and in concentrated acid water is present in less amount. Okay. So one note also given on the that concentration and strength of an acid. It is to be noted that the concentration and strength of an acid are two different things. Concentration refers to the amount of acid present in a definite amount of its aqueous solution, whereas strength refers to hydronium ion concentrated concentration produced on account of its dissociation in solution. So concentration and strength is totally different things. Okay, don't consider that if someone acids have more strength it will have highly concentrated also. It means not. Okay. A strong acid remains strong even in a dilute solution, whereas a weak acid remain weak in a highly concentrated solution. That's why these notes will be given. Now we move to the some properties of acids. Physical properties. Acids usually exist either in solid or liquid state at room temperature. Some examples are at, you can see acids have usually have sour taste. Mineral acids such as HF, HCl, HNO3, H2SO4 are highly corrosive and burns the skin where brought in contact. HCl turns skin to amber color. HNO3 turns skin to yellow. H2SO4 develops black stains on skin. They conduct electricity in solution. They turn the color of blue litmus solution or paper from blue to red. They turn the color of methyl orange solution to orange pink. And you have to read some acids and their sources, okay, because this can be asked in exams. What are the different sources and their chemical formula, etc. Chemical properties. Now we move to the chemical properties of acids. It may be asked in exams, important. Chemical properties. Reaction with active metals. When acid react with active metals to liberate hydrogen along with the formation of corresponding metallic salts. Okay, so you can see here that whenever metals react with any acid, they forms a salt and hydrogen gas will be liberated. Okay, in example you can see Mg plus 2HCl, MgCl2, it's from magnesium chloride and hydrogen gas is liberated. Okay, Zn H2SO4, ZnSO4 formed and H2 gas is liberated. Whenever you have any confusion or you want to something in the chapter, when you go through the chapter and making notes and you have any doubt, you can directly contact me. Okay, can be make a separate video for you. HNO3 is a strong oxidizing agent and only Mg and Mn metals liberate H2 with dial HNO3. Okay, so HNO3 is strong oxidizing agent. Okay, and only Mg and Mn metals liberate H2 with dilute HNO3. Reaction with bases. Reaction with bases, we know that when acid and bases are reactive with each other, they neutralize the each other. Okay, so whenever you can see the examples at your home also, the eno etc., whichever are used for the indigestion problem, because of create due to the excessive amount formed in our stomach acid, so it react with each other and they neutralize each other. So you can see there, reaction with bases, acid react with bases to form corresponding salts and water. In this reaction, acid neutralize bases to form a salt. Therefore these reactions termed as neutralization reactions. It can be asked what are the neutralization reactions, so you have to be answer that. So look here, acid plus base, salt and water, they formed HCl, reacted with sodium hydroxide, a base, it forms sodium chloride and water. Okay, so you can see other examples also like that. Note is given also, because these are important things you have to not miss. A dibasic acid, say H2SO4, forms two series of salts. Okay, it is sodium hydrogen sulfate acid salt and sodium sulfate normal salt. A tribasic acid H3PO4 forms three series of salts. Okay, Na2PO4, Na2HPO4 and Na3PO4 normal salts. Now the reaction of acid with carbonates and bicarbonates or hydrogen carbonates. Acid react with carbonates and bicarbonates to liberate carbon dioxide gas along with the formation of corresponding salts and water. You can see example here, sodium carbonate react with dilute H2SO4. It forms sodium sulfate and carbon dioxide gas is liberated here. Okay, and water is formed. As a same example is other sodium bicarbonate. When reactive with dilute HCl, it formed sodium chloride. So you have to remember the note also that only alkali metal and alkaline earth metals hydrogen carbonates are known. Only alkali metal hydrogen carbonates exist in solid state. In the acid base reaction lead to the formation of an insoluble salt, the reaction does not proceed. Okay, if you can see acid base reaction lead to the formation of insoluble salt. Okay, because CaSO4 is insoluble, PbCl2 is insoluble. When they reacted, they formed these compounds. So these are insoluble, so no reaction will be take place. Okay, now we move to the reaction with sulfide. Acid react with metallic sulfide to liberate hydrogen sulfide gas along with the formation of corresponding salts. When they react with sulfides, as they formed the ferrous sulfate, their sulfate is formed and hydrogen sulfide. You can see here FeS plus H2SO4, FeSO4 plus H2S. So whenever in one term you can remember that whenever they react with sulfide, they release the gas H2S, hydrogen sulfide, or liberate the hydrogen sulfide gases. Reaction with sulfides and hydrogen sulfides, it is called bisulfides. Okay, bi means two. When two sulfide sodium sulfide is reactive with HCl, they form sodium chloride and sulfur dioxide gas will be liberated. This. And reaction with nitrates, it is also important. When metal nitrates such as NaNO3, KNO3 etc. reactive with concentrated sulfuric acid to form nitric acid. Okay, sodium nitrate and H2SO4, they form the nitric acid. However, lead nitrate react with both dilute HCl and dilute H2SO4 to form insoluble lead salt. They react with both. If we see the reaction with chloride, metal chloride such as NaCl, KCl etc. do not react with dilute acid, but one being heated with concentrated H2SO4 yield hydrogen chloride gas. Okay, they normally not react with NaCl and KCl. Okay, they not react with dilute HCl, but when they concentrated H2SO4, they react with concentrated H2SO4 and they formed a hydrogen chloride gas. Same from the for the KCl, it reacted with H2SO4 concentrated, it also formed the hydrogen chloride gas and potassium hydrogen sulfate. The above reaction is based on the fact that a less volatile acid displaces more volatile acid from its salt. Okay, since sulfuric acid is less volatile as compared to hydrogen chloride, the former displaces the latter from its salt solution. As we know that the strength of HCl is more than of H2SO4. Day-to-day uses of some common acids. Okay, you can see their uses from your course book also. Tartaric acid is used in baking powder, carbonic acid is used in cold drinks and soda water. It may be asked in one number question also. Acetic acid in vinegar, benzoic acid in food preservatives as pickle jams, jellies, etc. Boric acid for eye wash and as antiseptic. Oxalic acid for removing ink stains. Citric acid for food preservation. Nitric acid for cleaning toilets. Hydrochloric acid cleaning of metal surface, and phosphoric acid for as a fertilizer. Now we move to the acid rains. Okay, how acid rain is formed. Acid rain refers to the presence of excessive acids in rain water. The acid mainly present in the acid rain sulfuric acid. Okay, they are sulfuric acid and nitric acid. Sulfurous acid, carbonic acid, and hydrochloric acids. Okay, mainly these two, H2SO4 and HNO3, are present. These are formed in the atmosphere by the dissolution of gases like SO2, NO2, CO2, Cl2, released by automobiles and various industries. Okay, in the atmosphere, in the moisture present in the air. Okay, you can simply see here that the vehicles or the automobiles release these gases SO2, NO2, and they react with the moisture of atmosphere and they formed the acid rain. Okay, whenever rain comes, comes in the form of acid. These acids slowly fall on the earth as continuous of rain or snow. The acid rain is in no way desirable and can be checked only by controlling air pollution. Okay, so it will be only one treatment for that, to control the atmospheric pollution. So adverse effects are so many in their ecosystem, causing respiratory ailments. So these are the very things, and skin diseases in skin cancer also happen. Okay, due to if anyone comes in contact with the acid rain continuously. So the formation of acids in atmosphere occur through a series of complex reactions. Okay, a simplified reaction is are given for as follows. You can see here, when SO2 plus O2, the atmospheric oxygen, and moisture is there in the form of water, they form S2SO4. Okay, sulfuric acid is formed here, and here is nitric acid formed, like that, when nitrogen dioxide is reactive with atmospheric oxygen and water. So bases you have to read from your home. Okay, this is your homework: definition of bases and classification of bases. Okay, same as the acids, it's just vice versa of acids. Okay, classification on the basis of acidity and of bases. Okay, concentration of alkalis, then what are the alkalis. Okay, if you have any confusion, you can told to me. I can explain it also in next class. So meet you in the next class. Thank you.